Hello everyone, welcome to the walkthrough of our placement management system. This is an enterprise-grade desktop portal built on Java Swing, styled with the premium FlatMacDark look and feel for a modern Slack and Indigo Dark UI. When the users launch the app, they see this responsive split screen login page. The left side is a branding panel detailing the custom data structure and algorithm integrated into the system. The right side is a clean credentials card with the placement text guides. Here we can see the login page. So we have to log in as an admin. We are now logged in as the administrator by default. The dashboard displays the system insights containing four real-time metric cards. These cards shows the total number of students, corporate partners, active drives, and processed application directly queried from the database. Let's go to the student tab. The table displays all the students' records using the status pass. Now let's look at the DSA implementation here. In this tab, by typing CGPA range, post 8 to 10, the, the tree filters and renders only students matching this range in Pigo of log and average time. We also have remove filter node button also. First select the student, remove filter node button. This demonstrates BST deletion, handling the three classic cases, if nodes, child, single child, or two children. To temporarily hide a student from the active list next to the placement leaderboard, we just click on the sort by CGPA. This triggers our output divide and conquer merge sort utility, ordering records in Vigo of and log and time complexity. Additionally, we have to find a student by ID. This runs a has map index search providing Vigo of 1 constant type lookup. As you can see, the search extension speeds is printed in microseconds. Moving to the companies tab, here we display corporate partners. We have implemented a tree prefix tree for real-time name autocomplete. If we search for a prefix like T and click on the search, it returns TCS Tech Mahindra immediately. This lookup takes big of L time where L is the character length. This is also an add company button which dynamically opens a form to add a company profile and register a recruiter login in the users table. To browse active drives, we click Browse Drive Sequence, which utilizes a doubly linked list. This navigator uses forward and backward pointers, allowing the admin to step through scheduled drives bidirectionally without running heavy database queries. Now, Application tab handles the tracking of placement status. Let's look at three DSA components here. First, the undo stack. If we select an application, update its status, and realize it was a mistake, we can undo last changes. Like here, we can see update status. Hmm, Okay, now undo last change. It pops the action from the undo stack and reverts the status to its previous value. Second is the database backend FIFO queue. We can queue pending applications by reviewing, clicking View Pending, choose the FIFO queue backlog. The admin can click Process Next Candidate to approve the oldest application at the front of the queue. Third is the placement graph. Clicking the relations network opens an adjacency leads graph mapping student to applied companies. It runs a BFS starting from a student node to display all connected corporate partners and list students with overlapping application interest. Now, now we are logged in as a student. On the dashboard tab, we see the student metrics, academic branch, current CGPA, applied drives, and eligible opportunities. Let's go to the available drives tab. The student only see drives they are eligible for. The database query automatically filters out drives where the data doesn't meet the CGPA or backlog criteria. The student can select a drive and click Apply to selected drive to submit an application under the My Application. They can check the status of their submission. They can also select an application and click View History Status. This uses a single linked list to research and display a chronological timeline of all status changes for that application. Finally, we log in as recruiter. The dashboard shows recruitment stat, active jobs, applicants, shortlisted candidates, and offer extended. In the Candidates tab, the recruiter can select their active drive, view applicants, and update a candidate status to a shortlisted. Suppose we can check load candidates here. Now we can change update status. Then here we can shortlisted. We can do shortlisted. Okay, successfully updated. Once candidates are shortlisted, we navigate to the interview queue tab. The recruiter can select the drive and click the build queue. This builds a priority queue where all shortlisted candidates are ordered automatically by their CGPA using a max hit property. To invite the top candidate, the recruiter clicks Call Next for interview. The system pops the highest priority students from the queue, schedules their interview, and updates the database. And that completes our system tour. By backing up our desktop user interface with structured data representations like trees for autocomplete, BSTs for filtering, W-linked list for navigation, stacks for undo operation, FIFO queues for processing, priority queues for ranking, and graphs for relationships mapping, we ensure high performance, low search latency, and clean code architecture. Thank you so much for watching.